Hey Bears, so today we're going to talk about this concept of the triangle inequality theorem. So our learning target is that I can construct a triangle given 3 side lengths or 3 angles. Today's focus will be on the side length. Tomorrow we're going to focus on the angles. So our first question is, can a triangle be formed by 3 segments of any given length? Yes or no? Right now it's just kind of your thought. Let's say I think that's true. If I have 3 lengths, triangles, 3 sides, I can make a triangle, everything's good to go. There are no wrong answers there. Alright, so we're given 3 side lengths. Let's test my theory out. This one is 3 units, this one is 4 units, and the bottom is 25. However, I move these B values. I am never going to be able to connect them. That 25 is just too big. So already, my theory is kind of disproved. So what do we need in order to make a triangle? Let's see the next one. Can I form these B's around in order to make a triangle? Looks like they're kind of close here. If I tilt that angle a little bit more, get them a little bit near each other. There we go. All right. So it looked like 10, 17, and 15 were usable side lengths. I did make a triangle. They did overlap. Everything was good to go there. So what is the difference between 10, 15, and 17, and 3, 4, and 25? And hopefully, obviously 3, 4, and 25 have single-digit numbers. These don't. You can make triangles with single-digit values. Hopefully we're not thinking that far. But kind of think more in terms of, are the numbers close together? Are they super far apart if you think about a number line? And that's where we're kind of going with this theorem today. So I'm going to use this thinking box to kind of explain the rest of the assignment today. So we have this concept called a triangle inequality theorem. And this theorem states that 2 side lengths of the triangle must be longer than the third. And that being said, if we go back to our first triangle, I hope those words are still there. 3 plus 25 is 28. That's automatically bigger than 4. However, we didn't make a triangle here. So what this theorem, that did stay good. So what this theorem states is that if you have sides A, B, and C, so we have a side length A, we have a side length B, we have a side length C. A plus B has to be greater than C. A plus C has to be greater than B, and B plus C need to be greater than A. And I think those are the only 3 choices. So no matter what 2 side lengths you pick on your triangle, if you add 2 of them together, they have to be greater than your third. So let's run through some examples that do work. If we have 4 plus 5, we have a triangle with sides 4, 5, and 6. Let's test those out. So first sides are 4 plus 5. Is that greater than 6? That's true. If I take the first and last side, is 4 plus 6 greater than 5? That's 10. That's true. If I take my last 2, is 5 plus 6 greater than 4? Yes, that is true. So you want to run through each kind of combination of all of your side lengths in order to determine if it's true. Because it only takes one side to make them not true. And let's say, what if I change this 4 to a 1? So that means 1 plus 5 needs to be greater than 6. 1 plus 5 is equal to 6. But if you go back thinking about our inequalities, greater than and greater than or equal to are different. It has to be greater than. So automatically this is not true. 6 is not greater than 6. So this is not a triangle. It will not make a triangle. It'll go back to how our original one was. They won't connect. So our goal today is really, can we add all of our side lengths together, determine if we're making a triangle, and then let's say I have 2 side lengths. I have 12 and I have 13, And I want to know which of these numbers could I make the fourth triangle out of? Sorry, I was trying to think of a fourth number. And if you're given that situation, really all you have to do is test it out. So 12 plus 5, is that larger than 13? True. Is 12 plus 13 larger than 5? True. Is 13 plus 5 greater than 12? True. So actually, if 5 works, the rest of them will also work as well. Once you find your minimum amount, then everything else is good to go. If this was a little bit smaller, if I change this value to 6, sorry, you guys know I'm not great at thinking on my spot with numbers, so I get you guys to help all the time. So let's test it out. 12 plus 6 is 18. That is greater than 5. So we're good so far. 12 plus 5 is greater than 6. That works. But 6 plus 5 is 11. 11 is not greater than 12. So in this case, 5 does not work. Let's try it out with 8. 8 plus 12 is 20. 20 is greater than 6. That's true. 12 plus 6 is 18. That's larger than 8. That works. 8 plus 6 is 14. That's bigger than 12. Again, once you find your automatically minimum amount, then we already know 10 and 14 are going to work as well. So that's kind of the second half of what you guys are going to be asked to do today. The first half is, okay, can you just say, is this a triangle, yay or nay? Add all your sides. 2 sides have to be greater than the third one based on this theorem. And then the second part will be, okay, if you know 2 sides, what could our possible third side be? So what you guys are going to be asked to do today is you're going to work through this Google form. So, sorry, I asked for your email. Your class period, that just helps me out. So again, which of these sides will form a triangle? Basically, 2 sides add together have to be bigger than the third one. So if we start with A, 5 plus 7 is 12. 12 is not greater than 12, so it's already not A. There's a helpful hint for you. So you'll work through all of these and submit when you are done. It should give you a score. No need to rush. Take your time. Make sure you're adding everything together. Everything's okay. Which of these, we'll make sure you're looking will form a triangle, will not form a triangle. So make sure we're looking at those negatives. Other than that, if you have questions, let me know. And you guys have a great day.